All right, so welcome back. Welcome back to the channel. So, over the last few videos, we have been learning about language modeling. So, in this video, we are going to um, go into recommender system. As I've seen in the title and the thumbnail, we are going to learn about recommender systems, what they actually are, how do these algorithms work. These are very sophisticated algorithms, and how do they actually work? And it's actually quite simple. I mean, you might have encountered recommender systems in like many applications current days, Amazon, Netflix, and so on. The list just goes on. I think even Hotstar has it, Disney Plus has it. You can just go there and after like scrolling through some, let's say, some content, games or apps or TV shows or something, you will be recommended some content. For example, Netflix, you'll be recommended some movies. In Amazon, you'll be recommended some products that they think that you are interested in. Right? How, like, the thing is, uh, how do they understand what you like? How can they understand what you like? So that is the main goal of this video. How do these algorithms work? And of course, the spoiler alert: deep learning is used to actually build these models that can recommend you products based on your previous searches or previous things you bought or previous things you watched. Based on that, they'll recommend new movies or content as per that. So we're going to learn about two methods. So there are actually two methods in recommender systems. Uh, it is content filtering and collaborative filtering. So I will explain both of them. Content filtering is, I mean both of them are very simple. I'll just start off with this. So let's say there are two persons. Just think of this two persons, and we have, let's say, two movies. Right. So based on that, or let's say three movies. Right. So let's say the person watched this movie and gave it a rating of 5, and second watched the second movie and gave it a rate of 0, and person one did not watch the movie number 3, let's say. And this person the second person watched the first movie and gave it a rating of 1. The second person watched the second movie and gave it a rating of 5. Or let's say this person did not watch this movie, second movie, and this person watched the third movie and gave it a rating of, let's say, 5. Next, how we can actually model this? So this is the problem, and we are going to have like many users and many movies, many TV shows, and many products. Right? Let's take the case of Amazon. So we are going to have many buyers, many customers that have bought multiple products, and then we're going to have many more products, uh, which some have bought and some haven't. So we'll collect a huge database of all these products, of all this data of what each person bought and what each person didn't. So how can we model this problem? How can we model this problem? How can we understand this problem? How can we come to an intuitional conclusion to this model? Or how can we move on with this problem, right? So the basic idea of recommender systems is to predict these probabilities. It's simply, we have broken this problem. With this step, we have broken this problem into I think a pretty simple step, just to predict this unknown reviews. So based on that, we'll predict a review for this, or we'll predict a rating or we'll predict a probability of how much this person is likely to like it. And by the way, I haven't mentioned these numbers are just the ratings. One have given. Let's say you have watched a movie and gave it an actual rating, then it'll work. Or let's say you have watched a movie or bought a product, and if you have, in the case of Amazon, it'll just be 0 or 1, because there is only like bought it or not, or even if you are gave reviews and all that. But not all gives ratings, so therefore you might just have like 1 or 0, either watched or not, or bought or not. Right? Watched the movie fully or not. If person watched the movie fully, then most of the times he might like the movie. Like most of the times, in the case of Netflix, uh you can just not watch it if you don't want to. But and also in the case of Amazon, you'll only buy products that you like and want, most probably. So therefore the computer can understand just by putting in 1 or 0, not 5 and not rating. But let's say everyone has to give a rating, I mean, just for fun. right? So let's say we have these missing columns, so we have to predict those missing columns, and based on that, we can set a threshold. In this case, maybe if the predicted rating is more than 3, then we should recommend the particular content to this particular person. Let's say this is something about around 3, then we should recommend that to the second person. So that is the idea of that is how we can model this problem. And the first method to solve this problem, to actually solve this problem, is to actually uh and it's actually quite naive method. I think Netflix also used it way back. I mean, yeah, I mean, way back when Netflix had it. I mean, actually, I don't know about it. I was just watched it on Google. That when you open Netflix, right, it'll ask you a lot of questions. Right, it'll actually ask you a lot of questions about like what is your favorite genre and what is your favorite let's say director, actor. What is your favorite they'll ask you a lot of questions. There is actually a huge form. I mean, I watched it in a video or something. They have to like fill in a lot of data about themselves, what movies they want, what movies they like, their favorite movies, they were their their favorite genres and all that, their favorite language, or I mean anything, their favorite actor and all that. And after asking all of these questions, right? So let's say we have two persons, right? Let's say we have two persons, number one, number two, right? And yeah, I mean, we'll draw the same representation, one and two. So this is one and two persons, and this is the first movie and second movie, let's say, or the first content and second piece of content. And what we'll be doing is, so no, not this. I'll just change this diagram into a little bit more. I mean, there is no need of drawing diagram. So essentially, let's say we have two features, or let's say we have one feature, genre, right? We will be collecting the favorite genres of two persons. So we have two persons, let's say, who have logged into our website. Let's say we are not running Netflix for now, right? So we have two persons. So we'll ask the genres of we are the favorite genres of two persons, right? Let's say we have only two users. Yeah, we only have two users for simplicity case. We'll ask the favorite genres of the two persons, and based on that, if the person has if their favorite genres match, right? If their favorite genres actually match, then what we could do is we could just take the genre of one. We would just take the movies watched by one person and just recommend those movies to the other person. So let's say we have two persons who have said that they love let's say action movies. So let's say they love action movies. So one person number one and person number two. So we are both of these have the same genre, right? Then whatever this person watches, we'll just directly recommend this to this person, whatever this person watches. So that is the idea of this, and based on that, we actually easily fill these gaps, right? So let's say we have one genre. Let's say both of them have opposite genres. They don't actually like this movie. So let's say yeah. So let's say both of them has opposite genres. Then this 5 is not going to carry here. Let's say 1 and 2 don't like the same genre. Let's say 1 likes comedy and 2 likes action. Then here third movie, the one might give a very low rating. One might give a very low rating for the third movie because second movie loves it very much, and maybe it's an action movie because second loves it. And then based on that, we could just put 0 here, and based on that, if if one doesn't like the second movie, we can just put 5 here because they have opposite genres. And this is actually quite a pretty naive approach. We could just collect a lot of features, right? That is why Netflix, when you're actually logging in, has a huge form that you have to fill, right? Based on what is your favorite genres and all the favorite genres, and you have to fill the document before signing into Netflix. And based on that, it will actually use this approach, which is called content filtering. We have specific features. Right? I want to press the word features. We have specific features that will that will just collect from the user, and based on that, we can just filter the content based on what person likes anything. And this is actually pretty naive because if you think about it, humans don't actually know what they want, right? Because I think there are much more smaller patterns, like not just genres and all that. I think movies has much more than just uh genres and actors and all that. There is much more to it. We can humanly collect that many possible features, and also a lot of users might be very frustrated, I mean, by using Netflix. So therefore, you have to find a better way, a much efficient way to calculate what people like and what people don't. And also we need a much better way, uh, rather than just collecting all the features, we need a much better representation, right? So that is our goal here. Well, how can we do it? Well, if you think about it, it's actually quite simple. It's actually quite simple. So let's say we have a lot of database. Let's say we have a huge database, or like huge amount of users. So these are all users. Let's say 1 to, let's say, million. And also we have let's say 1 to uh let's say 500,000 movies, right? Let's say we have 500,000, 5 lakhs movies. So what we'll be doing is we'll have a lot of missing values. Like, what are missing values? Let's say 1, 2, where, and bunch of numbers. Let's say ratings 5, 4, right? Bunch of missing fields. Don't want the rest. Yeah, we don't have like lots of data. Let's say. So what we could do is, right? We could, if you are aware of neural networks, I want you to be aware of neural networks. If you are not, well, I'm going to cover a little about that. So we're going to have something called neural network. It's an algorithm, one of the most powerful algorithms, I would say, in the current century, that has brought a lot of revolution. You probably know about it. So what we'll be doing is we could just pass this data, or train a neural network on this data, right? So for each person, right, we could have a neural network which could take in each person's and just predict how much he likes. So therefore we'll have so the x's will be, so the input will be the user, right? And based on that, we could actually predict. We could just have like a multi-class classification problem where the model tries to predict. So what happens in training is, when we are actually training the neural network, we'll just hide all of these numbers that we have already got. So we have got a lot of numbers, right? We have got a lot of reviews or ratings for each person. Each person gives a lot of ratings for a lot of movies, and of course he'll not watch all the movies. And given the ratings, whatever rating he has given, right, we'll just hide that ratings from the neural network, and the neural network will have something called weights in it, right? We'll have something called weights, which define the neural network's understanding of that particular data. And these weights will be updated, right, such that the model finds this value. So we'll have something called error function, which is nothing but the difference between the predicted value of the neural network and the actual value. So let's get the difference of the predicted value and the actual value. And the neural network is like, pretty basic. It's just like a simple mathematical function which just multiplies two numbers with the weight and the input. And we'll update this weight such that the product of weight and the input is equal to the actual output. And this weight will be updated by an algorithm called gradient descent, right? And if we update these weights, right, this neural network could actually understand the structure of this data, right? And the thing that I've just explained to you, the product of the weight and the input, it's just the operation of one single neuron, right? And then we could have multiple neurons, right? We have multiple neurons that are connected together, and each neuron has separate weights, right? And the first neuron gets some weights, and the output of these neurons just propagate through a very structured network which has many neurons in them, and each neuron has their own weights, and these weights are updated such that the output of this neural network is simply closer and closer as possible to the actual values, right? So the model just try to predict the actual values, right, for each person based on the input. I hope you got everything about. I just shared the basic intuition. And if you want, I think I do have some videos in my channel, the first videos. Just go to the oldest and just even if you are interested, just please watch them if you are interested in deep learning, right? So yeah, so we'll use a neural network to actually train that on this data, and simply we could just simply uh, after training this neural network, we could just simply pass this data and predict on these values. Right? After training, the model understands the nature of each of these persons. Right, after training, the model understands the nature, what these people actually want, and the model will find its own features. We don't know what the features actually are. They are mathematical representations. They define the nature of the particular person, and based on that, the model could predict the other values, the other ratings that the user might give after watching that movie, or how much a user might like a specific content or specific movie or something, whatever you want to say. So that's it. That is uh that is yeah. So that is collaborative filtering. Sorry, I forgot the name. So this is collaborative filtering, in which we will use a neural network simply, right? And then we would just we'll just take in uh, the user, and we'll just predict the given values. So the values we already have, we're going to predict those values, and then based on the features learned, based on the learned features while training the model, will have an error function, which is nothing but the difference between output of neural network and the actual value. And the model will try to decrease this error function. The model will try to get closer to the actual values, and we have something called weights, which define the output of the neural network. And after these weights are updated for many times, we'll finally get a neural network through which we could predict the unknown values. So that is the unknown ratings, right? So that is how collaborative filtering actually works. Thanks for watching. In the future videos, we'll definitely be carrying on with recommended systems. But thank you for watching.